Audible? Have you went through complete threads, all threads concepts? Very much? How many times? Less than one time. Thread pool. What is the general meaning of the pool? Huh? You might be seeing advertisement carpool. Did you see or not? What is the meaning of carpool? You know very well about swimming pool, not carpool. Pool is nothing but a container which contains similar kind of elements. Pool, a container which contains similar kind of elements. Similar kind of elements. In the swimming pool, what are the similar kind of elements? Water. In the swimming pool, only human beings will be allowed, not buffaloes, sarno. All are similar kind of human beings. In the car pool also, only human beings, not the elephants, not the buffaloes inside a car. Thread pool. Similar kind of threads in one container. Similar kind of threads in one container. Thread pool. Why do we require thread pool? Why do we require a thread pool? Why do we require to maintain multiple similar kind of threads in one container? What is the need of maintaining similar kind of multiple threads in one container? Thread creation process is a expensive process. Thread creation is a expensive thread creation process. It's a expensive process, expensive operation. With respect to system resources, thread creation is a expensive operation. With respect to system resources, thread creation process is a very expensive. Lot of system resources are involving while creating and starting a thread. Lot of system resources are involving while creating and starting a thread. After creating a thread, it's advisable to use the thread again and again rather than using only for one time. Once usage is got over, throwing away is not advisable. After creating a thread, use the thread again and again. After creating a thread, use the thread again and again rather than using only one time and throwing away. The reason is creating a thread is an expensive operation. After doing expensive operation, keep using the same again and again rather than using only one time. In order to recycle recycle any operation, in order to recycle any operation, we required a pool management. If you want to recycle any operation, we required a pool management. So something like create a thread with an expensive operation. After creating a thread, use it. Once usage is got over, don't throw away. Store that inside a container. Whenever you have a similar kind of requirement, go to the container, take the thread, use it. Once usage is got over, don't throw away. Once again, keep back in the container safely. Whenever same requirement is coming, again going into the container, taking a thread, using, once usage is got over, keeping back in the container. Inside a container, instead of keeping only one thread, if multiple threads are there, one customer can use one thread, other customer can use other thread. Maintain multiple threads in a pool. Share that pool to the multiple customers. Customer will be going into the pool, taking one thread, using, once usage is got over, setting back in the pool. Simultaneously, multiple customers can go to the pool, can take the threads, using and setting back in the pool. Simultaneously, if you wanted, same task to the multiple different users, different customers, different programs. Then going into the pool, one thread to one customer, one thread to one user, one thread to one program. Once usage is got over, again setting back in the pool for the recycle purpose. Creating a thread is an expensive operation. Instead of creating again and again, creating one time, multiple threads. Creating one time multiple threads, storing in a container. If multiple threads are there in the container, simultaneously multiple clients can get the services from a thread. One customer taking one thread, other customer is taking another thread simultaneously. Once usage is got over, setting back in the pool. Mainly, similar kind of activity required simultaneously to the multiple customers. Similar kind of activity required to the multiple customers simultaneously. Then, whatever similar kind of activity is there, with that similar kind of activity, develop a thread class. Create multiple threads to the thread class. Store all the threads in a container. Let one customer using one thread, other customer using another thread. Similar kind of activities required simultaneously to multiple customers. Similar kind of activity required to the multiple customers simultaneously. With that similar kind of activity, develop a thread class. Create multiple objects to thread class. Each object will be acting as a one thread. Store all in one container. Share that container to multiple clients. Clients will be going into the container, taking one thread, using that thread. Once usage is got over, setting back to the pool so that same thread will be utilizing by another client. Confusion? If same activity required to multiple customers simultaneously, same activity to the multiple customers simultaneously. Whatever that same activity required to multiple customers, That activity you can keep inside a thread class. Develop multiple threads. Store in a container. Let a customer taking one thread from the container, using once usage is got over, storing back in the container for recycle purpose. Come to the model thread class. Model thread is a subclass to thread, isn't it? Come on. Model thread is a subclass to thread. Model thread will act as a thread class. Overriding run method. Overriding run method. In the body of the run method, there is an infinite while loop. Inside a while loop, even no break also. If break is there, whenever break is executing, while loop will be terminated. No break also, infinite while loop. No condition is executing to continue the while loop. The plain true, infinite while loop. No break. It's a never-ending thread. You can call like a infinite thread. It's a never-ending thread. This thread execution will not be ending. Never-ending thread, infinite while loop, no break also. For while loop also, we are not supplying any Boolean expression or condition. We are supplying a plain true. True always will be true only. Never-ending thread, infinite thread. Run method containing a while loop, infinite while loop. It will be keep on executing. Once the run method execution got over, automatically thread will be going to the terminated state. Yes or no? Once the run method execution is fully got over, thread automatically will be going to the terminated state. Now here, run method containing infinite while loop, that infinite while loop, it will not be coming to the last iteration, keep on iterating, no break also, while loop is not terminating. Inside a while loop, you can consider like a three portions. Inside a while loop, three portions. First one is go to wait, second one is a for loop, third one is the release. Just to consider three parts in the while loop body. First one is go to wait, second one is for loop, third one is release. Go to wait calling statement, for loop, release calling statement. Go to wait calling statement, for loop, and release calling statement. Whatever similar task required to the multiple customers simultaneously, whatever similar task required to the multiple customers simultaneously, that similar task you can keep in place of the for loop. I just represented similar task through a for loop. For multiple customers, whichever task, whichever same task required to the multiple customers simultaneously, that you can develop in place of for loop. Here I am simply keeping one for loop for 10 iterations. In every iteration, printing name of the thread, loop index and sleeping for 100 milliseconds. 10 times for loop is executing. 10 times for loop is executing every time. Printing just name of the thread, loop index and sleeping for 100 milliseconds. Whatever common task required to the simultaneous multiple customers, that common task you can keep in place of for loop. Before for loop, go to wait. After for loop, release. Go to wait method, synchronized method. Check it out. Go to wait is a synchronized or not? In the same class, we developed synchronized go to wait, same go to wait, calling from the while loop body. This dot go to wait. Go to wait is a synchronized. This dot go to wait. It is taking object log of this, going to the go to wait. This dot go to wait. The current class non-static go to wait. While calling non-static go to wait, compiler is keeping this dot go to wait. This is a reference variable. Taking object log of this, going into go to wait. What is there in the go to wait? Giving a call to wait. That is nothing but this dot wait. Already credit taken. Object log of this. It's eligible to give a call to wait method on this. Yes or no? Come on. Already thread is taking object log of this. It's eligible to give a call to this dot wait. In the same way, release method. It is also developed in the same class. It is also synchronized. It is also synchronized. Giving a call to release. This dot release. Taking object log of this. Going into release. Calling notify. This dot notify. This object log is available. Eligible to call notify method on this. Yes or no? Instead of developing go to wait and release in some other classes, we are developing go to wait and release in the same class. We are calling from the body of the run method. As soon as thread is starting, it's going into run, it's going into infinite while, it's going into go to wait. From the go to wait, it is calling wait. Whenever you are creating a model thread and starting, whenever it is starting, it's going to run inside a run, infinite while, inside infinite while, giving a call to go to wait. That go to wait, calling wait. This dot wait, going to the waiting stage. If somebody calling release method, then only thread will be releasing from the waiting stage. If somebody calling release method, then only it will be releasing from the waiting state. Once it is released from the waiting state, it is executing for loop, which is a common task for every customer. After for loop execution, it is also calling release method. What will be happening while calling release method? That will come to know later. A simple understanding. Model thread class is a subclass to thread. Override run method. Two synchronizer methods are developed. One is for giving a call to wait. Other is for giving a call to come on. One is a go to wait, other is a release. Two synchronizer methods we are developing, and run method is override. In the body of the run method, infinite while loop, calling go to wait, for loop, then release. In the same model thread class, we developed synchronized go to wait and release. Now, if this task is required to the multiple customers, then maintain multiple threads in a container. Let one customer taking one thread from the container and use it. Please observe. Create multiple model thread objects. Store all multiple model threads in a container. If any customer wanted, going to the container, taking one model thread, using that. Once usage is got over, setting back to the container. Multiple model thread objects you can create and start. Store in the container. If any customer required model thread services, going into the container, getting one model thread, choosing that model thread. Once usage is got over, setting back in the pool only. In order to maintain multiple model threads in one container, in order to maintain multiple model threads in one container, we require a separate class. Let us see development of that class. Thread pool manager. It is managing pool of threads. It is managing pool of threads. It is managing pool of threads. To manage a pool of threads, it requires a container. I am choosing a container as a array list. It's a part of the collection API. It's almost similar to array. It will be acting as a container where we can store multiple elements. Array list I am choosing as a container to store multiple elements. All the elements are model thread objects. Already we have seen model thread. I want to manage model threads, multiple model threads. Inside array list, you can store any number of elements. Here, I am choosing array list to store model thread objects. Come to the init method. In order to initialize the pool, in order to create multiple model threads and storing inside array list, please go through everybody init. What we are doing in the init? Nothing. For loop is iterating 10 times. Every time one new model thread object is creating, starting, storing a reference in the array list through add method. Please go to for every iteration of the for loop. For every iteration of the for loop, creating one new model thread, creating one new model thread, starting the new model thread, starting the new model thread, storing the reference inside array list, storing a reference inside array list. Observe everybody. First iteration, model thread object is creating, starting. As soon as model thread is starting, it's going to run method. Inside a run method, infinite while loop. Inside infinite while loop, go to wait. Inside a go to wait. Now, the considerable point is which object lock is using to go to the waiting state. Which object lock is using to go to the waiting stage? In the first iteration, model thread object is creating, starting. Model thread object is creating and starting. As soon as it is starting, going to the run. Inside a run, infinite while loop. Inside infinite while loop, calling this dot go to wait. Inside this dot go to wait, calling this dot wait. Going to the waiting stage. Now the point is, which object lock is using? Bangalore object lock or Mysore object lock? Model thread object is creating and starting. Inside a start method, calling run method. Inside a run method, calling go to wait method. Inside a go to wait method, calling wait method. It's going to the waiting stage. By using which object lock is going to the waiting stage. Model thread objects, that is self objects object lock. SRO. This part is very important. Self objects object lock. Model thread object, it is having the object lock. Same object lock is using to go to the waiting state. This understanding is very important. Please observe. In the second iteration, second model thread object is creating new model thread, second model thread, starting. It is also going to run. From run, it is going to go to wait. From go to wait, it is also going to wait. Which object lock is used? Again, second model thread object, whichever created, forget whatever object lock is there, same object. In the third iteration, one more new model thread object created. Assume there is a third model thread object. Starting, going to run, go to wait. Which object lock is used? Whatever object lock is available to the third model thread object. Every model thread using object lock of the same object. Whichever object is representing as a thread, from that object, whatever object lock is available, same is used. Understood? This is very, very important. Totally 10 model threads are creating. Starting, every model thread is taking object lock of the same model thread object. Every thread is object or not? That object is having an object lock or not? Same object lock is using to go to the waiting state. Now, every model thread reference variable only we are storing in the array list. 10 reference variables are available in the array list. In the first iteration, one model thread is creating, starting. While it is starting, it's going to the waiting stage by using same object lock. Only reference variable is adding in the array list. Only reference variable is adding into the array list. In the second iteration, second model thread object created, started, going to the waiting stage by using wait method of the second model thread object. Reference is storing in the array list. Array list also maintaining indexes 0 onwards. Totally 10 references are stored in the array list in the indexes of 0 to 9. 0th index, 1 index, 2 index, likewise into 9th index from 0 to 9. Totally 10 references are stored. Totally 10 references are stored inside a model thread object. All 10 model threads are under waiting stage. References are available in the array list. Array list is having indexes 0 to 9. Every model thread is available under waiting stage. How each model thread can be released? Anybody? By calling notify on the same model thread object, isn't it or not? Please observe. If somebody calling notify method on the same model thread object, then only the current model thread will be released. Yes or no? 10 model threads are created, started, all are went into waiting. Only references are stored in the array list. Initializing a pool. 10 model threads are created, stored in the array list. All are under waiting state. All are under waiting state. Come to the second operation, get thread method. If any client require model thread services, if client require model thread services, client will be calling get thread method. If any client require if any client require if any client required model thread services, client will be calling get thread method. Return type is a model thread. First we are checking whether at least one model thread reference is available in the array list or not. Size method will be returning how many elements are there inside the array list. Pool is the array list. Pool dot size. I am checking whether at least one. If it is greater than 0, then minimum 1 available inside a pool. Minimum 1 available inside a pool. If minimum 1 is available, then remove whatever reference is stored at 0th index. Remove from the array list. Same you can return. Initially 10 are there. While calling first time get thread method, it is removing 0th index element from the array list. Same removed one is returning back to the client. Now in the array list only 9 will be. All that 9 will be shuffled from 0th index onwards. While removing 0th index 1, 1 index 1 will be moving to 0th index. 2 index 1 will be moving to 1 index. 3 index 1 will be moving to 2 index. Left shift by 1. Before returning first client, before returning model thread by first client, assume second client also called get thread method. Again checking what is the size. Now size is 9. Going inside. Again removing 0th index 1, sending back. Once removed 0th index 1, total number of references will be 8 only. From 0 to 7. Automatically shuffling by 1 left shift. Likewise, simultaneously 10 customers can get references from the array list. Before returning model thread reference by any of the client, assume 11th client also called get thread method. Assume 10 clients called get thread method, 10 clients called get thread method. Simultaneously, all 10 returned to the different clients. Now pool size is 0. 11th one also called get thread method. No reference is available in the pool. In that scenario, it will go to the else block, create a new model thread and starting. Then new model thread reference is written into the 11th line. Yes or no? Even 12, 13, 14 before returning any number of clients. Initial 10 clients, no expensive operation. Why? Because whatever thread readily available, that only returning. For 11th customer, performing an expensive operation. Creating a thread, starting that thread, and if very frequently more than 10 customers are coming simultaneously, then increase the pool size from 10 to 20 or 30 or 40. Got it or not? We are estimating like maximum 10 simultaneous clients. For that purpose, we are choosing 10 model threads. If number of users are increasing, if more model threads required simultaneously, increase the pool size from 10 to 15 or 20 or 30 based on your requirement. Get thread method. Returning reference of the model thread. Reference of the model thread. No matter whether that reference is from the array list or newly created, whatever it may be. The third very important operation. Once usage of the model thread is got over, client will be sending back used model thread to the setThread method as an argument. SetThread method taking one argument, client is calling SetThread method by supplying used model thread. Once usage is got over, sending back to the pool by calling SetThread method. SetThread method argument is a model thread. SetThread method receiving model thread from the client, first checking what is the pool size. If pool size is less than 10, then only try to add into the pool for recycle purpose. If pool size is less than 10, then add to the pool for the recycle for other customer. If pool size is already predefined at 10, then doesn't require to add whatever extra thread created to address simultaneous extra clients. Those threads you can able to stop. In the else block, we are stopped. We are not adding blindly all the threads which are returning by the client. Then the last operation, release. Whenever application is shutting down, whenever no more model threads required, whenever application is shutting down, if no more model threads are required, then what you can do? You can call release method. What release method is doing? Taking out model thread references one by one from the pool, calling stop method. One very important observation here, for loop index I, we are not implementing. There is no I plus plus. Why we are not using I plus plus? Every time we are removing one element from the pool sizes keep on decreasing. Every time pool size is decreasing. While starting an application, call delete method. While stopping an application, call release method. While running the application based on the client requirements, call get create and set. So, in general, maintaining a pool, mainly 4 operations: initializing a pool, housekeeping a pool, getting one element from the pool, setting one element to the pool. Init method, initializing the pool. Release method, housekeeping, cleaning completely pool. Get rate method, getting one element from the pool. Set rate method, setting one element from the pool. Setting one element from the pool. We developed one class to maintain multiple model threads in a container. Mainly 4 operations: init, get thread, set thread, and release. Now, let us share thread pool manager. Let us share thread pool manager to the multiple users. Whoever wanted model thread services, for them you can share thread pool manager. Whoever wanted model thread services, whichever client, whichever user, whichever program, whichever class required Model thread services. For that, share thread pool manager. Inside thread pool manager, get thread method for getting a model thread reference. Set thread method to receive a model thread reference. Used model thread reference. Guys, whichever user wanted model thread services, whichever client wanted model thread services, whichever program, whichever class required model thread services. For that, share the thread pool manager. In the thread pool manager, there is a public getter method, setter method. Getter method is returning reference of the model thread. Setter method receiving reference of the model. Got it? Now, let us analyze some users. Check it out, user 1. User 1 required services of the model thread. User 1 required services of the model thread. In order to use the model thread, you should require to call getter and setter from thread pool manager. That thread pool manager we are supplying to a constructor, assigning to the global attribute. Check it out. Thread pool manager is a global attribute in the user 1. Same is getting initialized to a constructor. We will be supplying thread pool manager reference while creating an object to user 1. So please observe, I am considering user 1 also another thread. I am just considering user 1 also one thread. User 1 thread required model thread services. User 1 thread required model thread services. User 1 thread required model thread services. Model thread services we can get through get thread method and set thread method. Through get thread method and set thread method. Get thread method and set thread method. We are sharing thread pool manager through a constructor. User 1 run method I am overriding. I am making user 1 also infinite. I am making user 1 also infinite inside a run method body. Inside a run method body. Infinite value. Infinite while loop. వీకెండ్ కాబట్టి ఛాన్స్
punches, so 8 covers, so batch, batch number, batch type, batch type. So, which is about the last method attention to eight types of new batch. Without the ratio, చేసినావా చార్జ్ చేస్తాను
Guys, overriding run method. User one also infinite thread. User one required model thread services. User one required model thread services. Let's observe one iteration of the user one. What it is doing? It is getting a reference of the model thread from the thread pool manager. It is getting a reference of the model thread from a thread pool manager. Simply getting a reference of the model thread from thread pool manager. Only reference variable. That is referring to an object. That object is a thread. That thread is under waiting. Is that no? Every model thread is under waiting or no? No idea. Every model thread is under waiting. Now, user thread got one reference to model thread. That reference is spawned into model thread object. That object is under waiting. How it can be released? Somebody has to call notify on same model thread object. Is that no? Somebody has to call notify on the same model thread object. What user is doing? User thread only executing the statement. It is a part of the user thread run method. What user thread is doing? After getting a reference variable from the array list, it is calling release method on the reference variable. It is calling th.release. Release method is a synchronized or not? Taking object lock of th, going inside a release. Inside a release, this dot notify that this is nothing but th. Th dot notify. User thread calling notify method on model thread. Isn't it done? User thread calling notify method on model thread. Whichever reference got from the array list, on the same reference calling notify method through release method. User thread executed release method. User thread made a call to release method. User thread made a call to release method. If user thread is making a call to release method on model thread, which thread will be releasing? Either user thread or model thread. Come on. Model thread. Huh? Model thread or user thread. Check it out. User thread is calling release method on model thread reference. Which thread will be releasing? Model or user? User thread is under execution. It doesn't require to release. It is only calling execute method, release method. It is only executing release method. It is under execution only. Model thread is under waiting stage. Model thread went into waiting stage by calling wait method, the same self model thread. Now somebody has to call notify method on model thread. User thread is calling release on model thread. In the release, notify on model thread. Model thread is getting notification. Model thread is getting notification. Model thread is releasing from waiting state. Please observe. Model thread is released from the waiting stage. If model thread is released from the waiting state, what it will be doing? Model thread is released from the waiting state. If model thread is released from the waiting state, it continues the remaining portion of run method. What is the remaining portion of the run method? For. So model thread started executing the common task whichever is required for every user. Yes or no? Model thread started executing a common task whichever is required for every user. Now model thread is executing. After calling release method, model thread started executing for loop. What user thread is doing? What user is doing? User is calling go to wait on th, that is on model thread. User is calling go to wait on model thread. User thread is calling go to wait on model thread. Inside a go to wait, there is a wait. This dot wait. User thread is going to waiting stage by making use of model thread wait method. Please remember. Yes or no? User thread is going to the waiting stage by making use of model thread wait method. Model thread object law. Model thread is executing for load. User thread is going to the waiting. How user thread is going to waiting? User thread is going to the waiting by making use of object lock of model thread. Model thread wait method. Model thread wait method. Sir, no. Model thread wait method. Model thread wait method. Model thread executing for loop. User thread went into waiting stage. User thread is under waiting. How it went? It went by making use of model thread wait method. Now, model thread after executing a for loop, what it is doing? After executing a for loop, model thread, what it is doing? This dot release. It is calling model thread release method, model thread notify method. Model thread is executing model thread notify method. Yes or no? Model thread is executing. Model thread release. Inside a release, there is a notify. Model thread notified. Model thread is executing. Model thread notified. Now which thread will be releasing? That's it. Which thread is released? Model thread is released. User thread is released. Model thread or user thread? Both. Come on. I already told user thread went into waiting by calling go to wait on TH. Isn't it or not? What is the TH? Model thread reference. User thread executed TH dot go to wait. Inside a go to wait, there is a wait. So user thread executed TH dot wait. Isn't it or not? User thread went into waiting stage by calling wait method on model thread. User thread went into waiting by calling wait method on model thread also. Now, model thread is calling release method on the model thread. Release method on model thread. Release method internally calling notify. Now model thread is executing notify method on model thread. Which thread will be released? Come on. User went into waiting by calling wait method of the model thread. If somebody calls release method on model thread, user thread only will be releasing. No matter who is calling release method on model thread. If somebody calls release method on model thread, user thread will be releasing. Here somebody is the model thread only. Sir, no. Model thread calling release method on model thread. Now which thread will be releasing? User or model? Come on. User or model? Model thread is under executing now. It doesn't require to release. Model thread only executed release method. Small common sense. Model thread is under execution. User only went into the waiting. User only called wait method on model thread. Model thread is calling, executing release method on model thread. Sir, no. User will be releasing from the waiting. User released from the waiting. Model went into the next iteration of the while loop. Model is going to the next iteration or not? Come on. Model after executing release method, it is going to the next iteration of the while loop. What is there in the next iteration of the while? What is there in the next iteration? Go to wait. It is again calling wait method on the self model thread object, going to the waiting stage. It served to one user. It is going back to the waiting stage. It finished its execution for one user. Whatever for loop common content is there, that is executed. It doesn't require to stay in the active stage. It's going to the waiting stage. Model thread is going to the waiting stage. What user thread is doing after releasing? What user thread is doing after releasing? User thread released from the waiting. After releasing from the waiting, it is taking model thread reference, sending back to the pool through set thread. Sending back to the pool through set thread. Sir, no. Now user is sleeping for 3 seconds, continuing the same process. In the next iteration, again it is calling get thread. It is getting a reference of the model thread from a pool. That reference is referring to model thread object. That model thread object is under waiting stage or not. That model thread object is under waiting stage or not. Come on. It is under waiting stage. How to release that? Somebody has to call release on the same model thread. User is calling release on the same model thread. Whenever user is calling release method on the model thread is releasing from the waiting. It is coming to the active and executing a for loop. While it is executing a for loop, user doesn't have to do anything. So user is going to the waiting by calling. Come on. Go to wait on model thread. Go to wait on model thread. User thread is going to the waiting stage. It's keep on waiting under waiting. What model thread is doing is, after executing a for loop, it is giving a notification to the user. I finished my work. Whatever work you assigned to me, I finished that work. You can come back. Model thread is calling release method on model thread. User is releasing from the waiting. User is thinking like, okay, model thread execution got over. I don't require this bloody model thread. Let me set back to the pool. It is setting back to the pool. Again, user is sleeping for some time. Again, starting the third iteration. It is getting a model thread from the pool through getThread method. Whatever model thread is getting from the getThread method, that model thread reference pointing to one model thread object. That model thread object is under waiting state. Somebody has to call notify on the same model thread reference. User is calling release on model thread reference. Release internally calling notify on model thread reference. Model thread is releasing. It is executing some task for the user. While model thread is executing some task for the user doesn't have to do anything. User is going to the waiting stage and asking to the model, once your main execution got over, give me notification. Till that, I'll be under waiting. User is under waiting. Once for loop execution got over to the model is calling release. Once model is calling release, user is releasing from the waiting. User is thinking like, model thread executed its assignment. I don't require model thread now. Let me set back to the Got it or not? This is very, very important. Like a user 1, I developed 3 users. You can assume like a hundreds together users are there to the thread pool manager. Sharing thread pool manager to the hundreds together users, whoever wanted model thread services. For them, you can share model thread, thread pool manager reference rate. 3 users for example purpose I am considering any number of users to the thread pool manager. Every user should have a reference of the thread pool manager in order to call get thread method, set thread. Get thread method, getting one reference from the pool, set thread method, setting back to the pool. Now manager class where application is starting. Manager class where application is starting. When our application is starting, create a thread pool manager, call the init method. All 10 model threads will be initializing or not? Mon. All 10 model threads are initializing. All 10 model threads are initializing. All 10 model threads are initializing. Now thread pool manager can be shared to any number of users. Thread pool manager can be shared to any number of users. I am sharing to 3 users. All 3 users are starting. These 3 users simultaneously going into the thread pool manager in the thread, using that thread. Once usage is got over, setting back. 3 users are constantly using model thread references from a thread pool by calling get thread and set thread from the thread pool manager. By calling set thread and get thread from the thread pool manager. Continuously for 500 seconds it's going on. After 500 seconds, assume you are stopping the application. All users are stopped. If all users are stopped, then we don't require a thread pool manager. We don't require a multiple model threads in the pool. Every user got stopped. Why? Because application itself getting shut down. When our application is shutting down, we don't require a model thread services. We are calling pm.release, thread pool manager release. Release method is stopping every model thread. All users are stopped. No user is using model thread. Yes or no? Confusion. Let us run this one. Please go through the output. Try to understand. seeing the recycle of same thread usage again and again? Check it out. Same thread, same model thread using again and again by different users. Isn't it or not? 10 model threads using by 3 users. Recycle. Once usage is got over, setting back in the hole, same thread will be considered after some time. Yes or no? This is very important topic. So go through again and again. Try to develop without seeing the material also. First go through. Develop by seeing the material 2-3 times. Then develop without seeing the material. And you can modify like without using go to wait and release. We can develop without using go to wait and release. You can call wait method at the place of go to wait itself. You can call release method at the place of notify method at the place of release by using synchronized blocks. Develop by yourself. So tomorrow